Hey everybody, it's early morning, drinking my coffee before work, and I thought I'd drop in a video real quick to explain. I don't know if many people will get hung on it. I know I did because I'm sort of a dummy, but I come from Commodore 64 where we had peaks and pokes, but they only operated on 1 byte, so it became this weird thing of, oh well, crap, if a color lookup table value is 3 bytes, how am I supposed to do that? So I thought I'd share with you real quickly how that works. I've already set up so that I have like 4 bytes of memory that are already maxed out at 255, and we can peek at those. Like I used 2000, so 2000 is set to it. 2001 is 255. Blah blah blah, and and just like on a Commodore 64, we can do something like poke. Hopefully, I don't hit anything important here, right? So we can also poke that memory, and we can peek and make sure I set that up right. Good. Okay, so we have 255, and this is about the place where the Commodore 64 like ended. We never needed to do anything more than this, but on the Phoenix, you're going to find you have to do a lot more than this, a lot, right? So color lookup tables are sometimes 3 bytes long, and when you get into sprites and graphics, sometimes there's an alpha sitting at the end of that, and it's 4 bytes long. So you may be going, well, how the hell am I supposed to do that using pokes and peaks? And the answer is there's derivatives of poke and peak that have a letter at the end of them that may not be clear as to what they are. I know in the manual I struggled with one or two because they said deek and doke in one of the descriptions, and it's actually peak D and poke D, but we'll get to that. So, going up the levels of peaking and poking, the next one we have is, I call it wide. I don't know what the W stands for, but I'll say poke wide, peak wide. And basically, what that is it's the same command peak, but it has a W at the end of it. And this time, if we look at 2000, we'll see that it's 65,535 because I've already taken all 4 of those bytes and set them all to ones. We also have the next level up, which is peak L. I got to look at my manual, which is 3 bytes long. You'll use this one. You'll use L's a lot because this is getting into color lookup tables and hex values for colors. And you see that it goes up to some ridiculous number. What is that? 16 million. And anybody that's dealt with 4 byte integers knows that int max is like this ridiculously large number. But what's fun is in basic, if we print that one, we get that's I don't know where the decimal comes from, but that's crazy cool. But I just like printing that number. So we have peak wide, peak long, and D. I don't know what D stands for, but these three actually allow you to peek and poke individual values of different byte links in, and 4 is the max that we get. And 4, you'll have to use a 4 one day too, because there's like I said, there's graphics channels that are red, green, blue, and then an alpha. So you know, we can do stuff interesting with this a little bit later if you want to see an example. We also have indirection operators, which is pretty interesting. And the manual mentions these, but I don't think it dwells on them long enough to show how cool they are. Like back to our original problem, or not even a problem, but back to our original peak, where we could get 255. We can do the same thing by doing this. And you go, well, wait a minute. Isn't the question mark the print operator on a Commodore? And the answer is yeah. So, but in SuperBasic, it isn't. It's an indirection operator. And depending on how you use it, depends on what it does. So I can also say something like 2000 equal, I don't know, 192. Then when I go back up here and print it again, you'll see that I changed the value to 192. So that it's a pretty neat indirection operator, and I've used it in a couple places, but I can already tell you that sometimes in basic code you'll look at the code for that, and it takes some getting used to, right? And you're like, well, okay, that's 1 byte, that's great. But what about 2 bytes? Well, this exclamation point does that job for you, right? Sorry, the sun's right in my face, and I can't even see my own keyboard. There we go. And that's how you would get that back out of it. And it's the same thing. We could set it if we wanted to as well. And that's pretty much, how that works. Uh, is there an indirection operator for the long or the L and the D? Not that I can find. So keep that in mind when you're using these that it's really just a shortcut for single and double byte memory positions. I think I had an example in here. Yeah, I did. And I can show you like one common way in which we use this. Like when we want to set a specific color, we'll have to set the red, the green, and the blue, of course, just like hex does in web HTML colors. And we usually do that through 2 hex digits, but for the most part, it's basically the red multiplied by the blue multiplied by the green will be in the final number that you need to set in memory. In our specific case, I happen to know here that my computer, for some reason, is D848 is in MMU position 0 is actually the LUT that the background's using in text mode. So if I generate random colors and I flop that out, we could actually see something weird, like you could actually see the background of the text window close. And I actually print out the numbers here. And the reason I do this is sometimes I just sit here and watch it until I see a really cool one. Let's see if I get a really dark color. Well, 0. But sometimes I'll sit here and just try to see if I get some kind of cool Monokai looking thing, and then I'll save the number, and then I'll use it somewhere else. But yeah, so you can see that poke L is used a lot. We can also do dumb stuff too, like what's something fun we could do? Let's turn bitmap. Bitmap is on, right? Whoop. Type in blind bitmap clear 3. There we go. There. Let's say vload index. Whoa. Sorry guys, I'm having typing difficulties again. So we could do something like and let's say for x equal, what is it? D. Yeah, I'm flying off the cuff here, so don't get mad at me. That's a 3-bit color value too, right? So we can say poke L, 3-byte poke L x random 65 5 35 x. Yeah. So I can sit here and mess with the LUT behind the scenes that was drawing that bitmap, and just change the colors. This is like some of all the crazy stuff that you can do. That one actually looks pretty cool. Anyway, D 000 to do 400 happens to be where LUT 1 is for the bitmap, and I've loaded that bitmap into the background, and I'm just playing around with it. I actually have a PAL LUT that was put in there because I'm walking through somebody else's tutorial on Discord about how to put these images in here, and I can't figure out how to get the bytes of the LUT in the right positions. But that just led me to playing around with this stuff. Just led me to the idea that probably everybody doesn't know how the peek and poke commands work, but that's pretty much how that works. And yeah, I'm gonna go to work now and be miserable for about 8 hours, and I will see you guys in the next mini tutorial.